Hello, I'm Spencer. As I mentioned, I'm a data scientist at Branch International. To differentiate a little bit, we're not the other branch, not branch analytics. We don't do mobile analytics. We use them in our mobile app, but we do something a little different, which I'll go into in a minute. I'd like to talk to you about early stage infrastructure and machine learning. And so let's dive in. So first of all, as I mentioned, I'm a data scientist here. I've been at Branch for about 2.5 years. After 2.5 years, they finally put me on the career site. I'm hoping that in another 2.5 years, maybe they'll turn me around. We'll see. I've been involved in a bunch of different stuff. We're a team of about 10 people now. When I joined, it was, I think, four engineers, that is. So I've been involved in a lot of different parts. Been involved in primarily working on our credit model. But what that's meant is there's a bunch of infrastructure related to that. We collect a bunch of data from our users. We have to clean that data, of course. We have to develop a bunch of features. We have to build models. So I've been involved in the whole end-to-end process. I've been involved in sort of building that up and making sure it's a product that works for the business. So I'd like to try a little video here. We'll see how this goes. Just to give you guys a little bit of a sense about Branch. We're a slightly different company than a lot of Bay Area companies because we don't operate in the United States. So a little video. This is an ad that we put up in Nigeria. That was one of our customers in Lagos, Nigeria. Sort of interesting, right? We're not operating in the United States. In fact, this company started in Kenya. Oops, if you want to go back one more slide. This is our team in Kenya. They're based out of Nairobi. We started in Kenya, I guess, about 4 years ago now. We started out delivering loans. We still do loans, but we're now working on other things. We're trying to be a mobile bank, so we're offering a lot of different financial services, and we started recently doing savings. But we do lending right now in Kenya, Tanzania, Nigeria. We started more recently in Mexico and India as well. So you can see, operating in a lot of different markets outside the United States, primarily focused on lending and primarily focused on sort of people who are traditionally underserved by banking institutions, people who are on mobile devices, who are using mobile money, who might have access to sort of all that early technology that's showing up, but they haven't been recognized by traditional banking institutions yet. So we found a great opportunity. We've got millions of customers. We've done millions of loans at this point. I guess the growth has been sort of crazy because it turns out when you find a market that's underserved, it's easy to grow. So anyways, our mission, again, to deliver world-class financial services to the mobile generation. I want to give you all this context because it really relates to what we actually built in our machine learning. So a little bit. Uh-oh, now you're disconnected from this guy. That's okay. This guy's disconnected. There we go. Great. Cool. I'll click. So a little bit of our app. You're not actually going to be able to download and use our app because you're not a Kenyan with a national ID in Kenya, but you can at least see it here. So this is a little bit of our sign-up flow. We pride ourselves in being really easy to install, set up, and get started with a loan. So some of the stuff we'll ask for right off the bat, we'll ask for your name, your national ID, your date of birth. At that point, you're off and running. If we like what we see on your device, we'll potentially give you an offer. We'll give you a loan. You can get that loan. You'll receive it through your bank account, through your mobile money account, depending on the country. And then hopefully, about a month later or so, you repay that loan and move on to larger loan sizes. So one of the things you'll notice in here, I'm here to talk about machine learning, but where's the data? This user only entered their name, their national ID, their date of birth. Not a heck of a lot to create a credit model off of. Certainly when they're entering their own age, you can't really trust that piece of information. So what do? Let's talk about what happens behind the scenes with specifically our credit model, piece of infrastructure I've been primarily focused on. So steps that you'll probably recognize that are pretty traditional in machine learning: gathering data, generating a bunch of features, you've got a prediction. Our data is sort of interesting. We collect a bunch of phone data. We collect stuff like text messages, installed apps, contact lists. We, of course, also collect information from where you click around in our app. All of this is information that our users are willing to give us permission to download because they don't have access to normal, traditional financial opportunities. So in exchange, we get all of this data, and this is what we get to credit score people on. From this data, we extract a bunch of really interesting information. We extract stuff like your bank account balance. This sounds a little surprising, perhaps. How do you get a bank account balance from this data? Well, I mentioned mobile money. In a place like Kenya, there's a thing called M-Pesa, which a lot of the economy flows through. You're texting money back and forth, basically. You're getting receipts on your phone in text message form. Turns out when we download those receipts, we can see what your balance is, we can see your transactions. We end up having a source of more traditional financial information that becomes really valuable. We look at a bunch of other things as well, social stuff like the number of contacts you've got in your phone, whether or not you've read our FAQ on the app, that ends up being important. Have you installed the Facebook app? Sort of what's your ecosystem of apps on your phone? All of these things are features that we extract from that data. And finally, of course, we take all those features. We've got some traditional machine learning systems. We predict your likelihood of repayment on a loan. We think that looks reasonable enough. We're going to give you a loan offer. You hopefully take it. Then a month later, pay us back, assuming our prediction's correct. But that, of course, is the crux. So with all this, we've built machine learning into our product. But how do you do it? That's a good question to be asking right now. Specifically, if you're sitting in your seat going, hey, we're a small company. How do we do this? So I'd like to provide you a little bit of insight from my experience building out what you just saw, that credit system, building out in the context of branch, and building out specifically what we're going to call a feature service. So as you guys may have seen in the slightly earlier talk, 2 talks ago, only an hour or so ago, Airbnb is building this really crazy stuff called Big Head. I look at this and go, wow, wouldn't it be nice to have this? The problem is I also see this. It's a lot of people involved. There's a team on Zipline that's larger than the whole engineering team at Branch. But we also have a mobile app to keep. And we also have integrations. We have a bunch of other stuff we have to build. We can't afford to build infrastructure like this. And I assume a lot of you guys can't as well. So what do? What can the rest of us do? We can be strategic. That's a really key detail. You can build machine learning infrastructure, as I hope I'll be able to demonstrate to you. It's not too hard to do, but you have to focus. You have to pick specific problems where you can deliver a lot of impact and where you can actually get results achieved. So one of those areas that I'm going to really push for you today as a really important area to think about is what I'm going to call a feature service, focusing specifically on developing your features and making that a part of your machine learning pipeline that really delivers. Okay, so let's talk feature service. Uh-oh, now this one. So what does a feature service do for me? I'm going to highlight, I guess, a bunch of different points here. But one of the first things you'll notice as we go in deeper is this is a thing that lets you develop your features faster. Why? We've got consistent feature definitions. These help us reduce bugs. We can speed up feature calculations with a common framework. And we can make feature discovery and sharing really easy. These were all goals that we set out to achieve, and we're going to dig into a lot more detail on how we actually went and did that. Okay. So let's take one little step back, though. I'm talking about a feature service. You're probably not quite there yet. If you're building a machine learning system, don't quite start there. You really do want to start simple. In the Branch story, we really started simple. We didn't even have machine learning at the beginning, and you shouldn't necessarily either. We had a bunch of people we hired in Kenya who did manual loan review. They looked at text messages and said, hey, can this person receive a loan? Obviously not a scalable solution. You get to 1 million customers, you can't do that. But we started basic. We had models as simple as linear regressions running on Excel. That, of course, we built out eventually. We had systems built in Python. We started basic. You're going to iterate. You're going to patch things together. You're going to make it a little bit more complicated. But at some point, the basics are going to only get you so far. A patchwork system will eventually flatline. This is a demonstration of what our model AUCs were. Ours weren't actually these numbers. They were better. But about a year ago, we did find that we weren't really able to improve on our model very much. We were adding new features. We had a lot of really great data. But there were a lot of bugs that were holding us back. There were a lot of issues. And so we couldn't quite get to that next level. We'd iterated on the basics. But where do we go from there? So what do you focus on beyond the basics? You guys probably recognize all these simple components of a machine learning system. I really wanted to boil it down to the basics here. Gathering data, building features. These seem like obvious places to start. If you don't have a good foundation of data, if you don't have clean data, you can't build clean features, and therefore you can't have a successful model. In our world, we had decent data. We invested some time and made sure it was clean, but we were finding we had a lot of problems building out really useful features. Specifically, we found that we had differences between development, training, and production. These three environments, as we worked in them, they were all working off of slightly different code. That slightly different code, of course, led to a lot of bugs. Additionally, we had inconsistent feature definitions. So we defined features using different code. Every single feature was a custom piece of code built to build that feature. Guess what? A lot of bugs. We'd fix one feature, you'd have another one that was broken. And finally, feature creation, because of all this custom code, because of the patchwork system, it was becoming really slow and cumbersome. In particular, during training, feature creation became a major bottleneck for us. We got to the point where it would take a few days to train our model. A few days meant that, guess what? We weren't really retraining our model, except on maybe, we'd wait like 3 or 4 months before we decide to go tackle that again. Not really a good iteration process. And as a result, we weren't improving our model anymore. We weren't able to spend the time and energy and effort to do so. So we decided to invest in our infrastructure. And specifically, we decided to invest in our features. And we decided to invest in something I'm going to call a feature service. OK. Let's finally get to actually what that is. What is a feature service? So in my definition, you're going to hear a lot of definitions probably about what a feature service is. But the one I want to give you is a feature service is a tool that helps you create a feature vector for a specific object at a specific time. And we'll talk a little bit more about the time piece. That might not be relevant for everybody. But the main idea is that you've got a feature vector that's being created. So to give you guys a little bit more of a concrete example, this is the black box of a feature service. I might ask this feature service for a bunch of features related to a given user. In our world, this might return stuff like the average bank balance, or the number of referrals, or whether or not this person's actually read the FAQ. You'll recognize, some of these features are numeric, some of them might be categorical, some of them might be Booleans. But together what's coming back is all those features that I'm going to feed into later parts of my pipeline. Another key piece of the feature service I mentioned was time. I might be interested in historical features. In our case, I might care about a user, but I might also care about what was that user doing back in 2016. So I might ask the feature service for the user's feature vector back in 2016. Again, I'll get some numbers back, but they're going to be slightly different. It's based on different data. In this case, maybe the user had more money, but they hadn't made any referrals yet, and they hadn't read the FAQ. Not a good sign. Definitely shouldn't give them a loan if they haven't read the FAQ. OK, so let's take a look really briefly at the API, which I think highlights some of these components a little bit more deeply. So one of the first things you'll notice, these are 3 examples of requests that we send to our feature service, really our most simple version of the API. One of the things you'll notice, the first bit is a feature name. So a bunch of different feature names in here, stuff like bank balance, loan repayment. A second piece is a version. We'll touch a lot more on versions a little bit later. But versioning ends up being really important for us. As we fix bugs, as we modify these features, and we update them, we like to keep track of versions so that we can maintain backwards compatibility and deal with other issues. The next piece, a primary ID. In our case, it's usually a user ID. It could be a loan ID. It could be a date. In your world, maybe it's a photo ID. Anyways, whatever types of objects you guys are working with and building your machine learning systems around, a primary ID would represent that. And finally, we sometimes like to include a date for historical purposes. So if we're building a model and we want to look back at historical features, we want to train off historical data, we'll include that date as well. OK, let's answer a question that may be in your mind right now, which is why the heck did you guys go and build something custom? This is a really good question. We're a small company. Generally, it's not wise for a small company to build something super custom, especially if it's not sort of their core front-end product. In this case, we, about a year ago, realized we had this problem with our features, realized we really need to improve the situation. We knew we needed to invest in some infrastructure. But when we looked around the ecosystem, we found a lot of tools, but we didn't find any tools that were working on features specifically. That may be changing in the future. Maybe Zipline becomes a big open source thing, like Airflow, for example, that we could leverage. But at the time, we didn't find that. We found this gap. And so as a result, we decided we really needed to invest and build our own system. Thus, a feature service. So let's talk a little bit more detailed about what we actually built. I want to break it down to 3 different components. The first two components are related to infrastructure. So we built both a server. basic server infrastructure for holding this thing we call a feature service. We built some caching into the system, and I'll touch on that in a little bit, why that's important. And then the third piece is inside that server, we actually built an additional Python framework. We chose Python as a language we were all familiar with, a pretty simple one for data scientists to get up and running with, a lot of experience there. So a Python framework that actually delivers feature definitions and creates the features. Okay, let's start diving in on the server infrastructure. I want to give you guys a really good idea of all the design choices we made, why we made them, and then hopefully that gives you an idea of what you could end up going and building yourself. So one of the first problems that we ran into was data source dependencies. As we added new data sources, for example, data source B here, we found that there were a lot of interdependencies between different parts of our machine learning system. When we were in development, we had to connect to both data source A and data source B. In training, we had to do the same. In inference, during production, we had to connect to all of those data sources as well. In each of those situations, we had this dependency on the data sources. One of the first big wins of a feature service is abstraction. So the feature service sits in the middle. No longer do I, as a developer, need to know about the data sources that are downstream. I just need to know how to connect to the feature service. Likewise, for inference, during production, we can connect to a feature service rather than connecting directly to those raw data sources. The same process can occur for training. So first big win, abstraction. A second big win for us, we found that we had this problem with recreating feature logic. I mentioned how we had a lot of bugs. So one of the big sources of bugs was that in production systems, we had slightly different code than what you might have when you're training. These were slightly different environments. They had slightly different requirements. During development, we had a completely different set of code. People were creating custom code all the time to develop the features that they wanted to explore or model with. This, obviously, a big problem. Inconsistencies between our training, our development, and our production systems. So, again, centralization. The feature service brings all of those features together in one location. No longer are features being computed separately in a production system versus in a development system. In the development environment, you can connect to the feature service, and likewise in production, you can also connect to the feature service. The feature service is running the same exact code to develop the same exact feature. Again, reducing a lot of bugs for us. We found an additional problem. Machine learning was working really well for our credit model. So of course, the CEO was like, great, machine learning, this is cool. Let's do more of it. So pretty soon we had a model helping us with our customer service. We had another model helping us with collections. We had another model that predicted gender, which we needed for some regulatory stuff. There was an explosion of machine learning at Branch about a year ago. Today, 2 of those models are dead. They're in the dustbin because it turns out it's hard to maintain all of these different systems with a lot of different code. So again, feature service, a big win for us. Now, all of that code is living in one place. When I go build the first model, for example, our credit service, we built a ton of features out for credit scoring. When we're now in the process of building out a long-term value prediction model, guess what? Turns out a lot of that data, a lot of the features that you want for credit scoring are very similar when you're building a long-term value model. With a feature service, we don't have to rewrite any of that. We utilize the same code, the same central source of truth in the feature service. And when we're adding a third model, say, again, using the same features from the feature service, no need to recreate anything from scratch. So this has been a big win for us, particularly on development time. It's meant that the CEO getting excited about machine learning is something that we can actually deliver on now. So in summary, just to sort of highlight the wins from the feature service and the server piece of infrastructure specifically, we got abstracted data sources, we have shared features, and we have consistent features. So let's talk a little bit about caching now and feature storage. So we ran into a problem where we found that we were recomputing features. Users keep coming back to our app. We're an app that drives repeat usage. And those users would come back asking for a new loan, another new loan, another new loan. Each time they come in, we're recomputing a bunch of features. First time they come in, we compute a bunch. Second time, we recompute all those same features again. We were throwing all that information out. They might come back a third time. Again, we'd recompute all of those features. This ended up being a big strain for us both in terms of money and server capacity, but also this was a slower process for our customers because they had to have all these really slowly calculated features recomputed every single time. So another big win from the feature service is this was a central source of truth we could connect to a central data storage system. So in addition to the server itself, the feature service, we utilize a feature storage. In this case, it's something as simple as like a DynamoDB database. So feature storage is there. Basically what happens is when a feature comes in and we compute it, we can save it to that cache. When we request that feature again, we go straight to the data source, and we don't have to recompute. We can simply pull it from storage. There's great side benefits from this, which are you now have a central source for all of the features that have ever been computed. And guess what? Analysts get really excited about all that data. This became a really good source for analytics purposes, looking back historically and saying, how did features change over time? It also, when you maybe saw the Zipline talk earlier, they did a lot of monitoring off of their storage system. It's also enabled us to do a bunch of monitoring. So features change over time. You want to know how they change. You want to see if features are no longer relevant. All of that is enabled because you're storing your features in one central location. Okay. And then another big problem that I mentioned early on, training was a bottleneck for us. Nowadays, with this feature storage serving as a cache, when a user first shows up, we perform that initial inference. We compute a feature vector for them. We store it. When I show up and I want to develop a new model or play around with that LTV model we're working on, I can go straight to feature storage and pull those features. No longer do they need to be recomputed. I don't need to know how to do that. I can just go straight to feature storage and utilize those. And then finally, the big, really big win for us was when we actually go and do training. Again, we're going back to the feature storage. The features have been computed. We've saved ourselves. As a result, we've gone from multiple days of training, like 2 days worth of time just to get our features built, down to a few hours. Again, because we're not actually running any of that computation. It's already been done for us. The user showed up 2 years ago. We got features then. So big speed up for us by using a little bit of simple caching. So feature storage, in summary, we've removed recomputation of features. We've enabled analytics and monitoring. And as a result of all that, we've also increased our training speed, which was a big problem for us. So let's talk a little bit about what we actually built with this. So as I mentioned earlier, DynamoDB for feature storage, a pretty simple database to work with. The feature service itself is a simple Flask app deployed on Amazon's Elastic Beanstalk. Something that hopefully you guys will notice is none of these tools are anything that fancy. These are all pretty out of the box. In our case, Amazon tools, you could use whatever cloud provider you've got. But what I really want to highlight here is that it was simple. While there were a lot of different things built into this, the tools that we actually end up using for the infrastructure are pretty basic. Okay. So to summarize all of that, simple infrastructure solved many problems for us. This is a diagram of it all put together for you. And just to sort of refresh ourselves, feature service served as a common source for features. It allowed for data abstraction. And then the feature storage itself allowed for caching, analytics, and monitoring. And finally, we kept it pretty simple. We utilized third-party tools. We utilized open source frameworks. We didn't build anything too fancy or custom there. We used something as simple as Flask to get this whole thing deployed. OK, cool. So let's zoom in a little bit. You're probably now wondering what happens on the feature service, on that server itself, what's running in there. How do we go from text messages to bank balance, for example? Good question. Let's dive in. So inside, one of the other pieces that we built inside the server was we built a framework. This ended up adding a lot of other benefits for us. So this framework we composed of a few different component pieces. Within the framework, we have this idea of a feature. Probably not too surprising. But a feature is composed of an extractor, or 2 or 3, and a bunch of transformers. The basic way that these work together for us is an extractor connects to the raw data source, pulls a bunch of data. There's code to deal with all the different data sources, all the different nuances of our different data sources. That's all bundled up in this object called an extractor. We then have a series of objects called transformers, which are modular components doing simple things like filtering or mapping or reducing. So to drive this home, I have a little bit of an example. This is one of our features, average bank balance. Our average bank balance pulls from text messages using the extract SMS. You'll remember that text messages in our world actually contain bank balances. A little bit mind-blowing, but that's what we have. So extract SMS pulls those text messages. At that point, we've got a series of transformations in a pipeline. We might pull out the specific text messages from banks. We might pull out the balances from those messages using a different transformer. And then we might average those together using a third transformer. Collectively, this defines a feature for us. And at the end result of all of that is we get a number spit out, which is your average bank balance. One of the cool parts about all this is that these components are modular. They can be shared. So you can imagine our average bank balance feature looks very similar to our maximum bank balance feature. They both share a common extractor. They both deal with parsing the text messages the same. The only piece that changes is a little bit of math at the very end. So that modularity, a big win. It meant that we had common code that could be tested and reliable. And it meant that when we wanted to develop new things, we could use those same components. We didn't have to start from scratch every time. OK, so let's look a little bit at some code on how we actually did this. One of the big differences, one of the lessons learned from Zipline, is that we actually decided to stick with Python. So you'll notice this is some Python code up here. One of the first things you'll notice at the top is everything is built from some base classes. We have, for example, imported here feature and transform. The base classes, of course, have a lot of common logic. One of the really cool side effects of having some base classes and a common framework is we could do some interesting automated testing, again, helping us reduce some bugs. You'll notice that the features are versioned. So all of the transforms, all the extracts that we import, they come with a specific version attached to them. We'll talk about this in just a minute in a little bit more detail, but that ended up being a really important piece for us. You'll notice this, of course, is all in Python. So the advantage, of course, of building a framework in a language as simple as Python is that you've got all of the flexibility of something like Python. In this case, I've added a constant to this class. It's just a list, nothing too fancy. But all of the flexibility that is Python is still there. I can still import NumPy, I can still import SciPy, I can utilize all of those things in my various features that I might want to build. Down here, we see a chain of transformations. We see the extractor, and then there's a series of transformations. Most of these are common transformations that somebody else wrote and I just imported, except for the last one here where I decided I didn't really want an average, I wanted a weighted average. So again, we're working in the world of Python. It's all pretty flexible. I could go and build my own custom transform, stick that into the pipeline as well. So as a data scientist coming in, you can see if I want to add that new feature, it's not going to necessarily be too complicated. I need to know maybe which data source I want to pull from. I need to have a rough idea of the transformations I want to add. But the amount of code that I end up writing and the amount of sort of debugging and testing that I need to understand and all of that is pretty limited because a lot of other people have built those components and I'm just utilizing them. OK, so versions. I mentioned versions a few times. Let's actually talk about versioning. So one of the big benefits of a feature service, again, that central source of truth. One of the things that we found, of course, is that features have to change over time. Bank balance, for example. We discovered bugs all the time in our features. You can imagine a buggy bank balance, version 1. We've got a credit model trained on version 1, the buggy version of bank balance. Somebody comes along and says, hey, I want to fix that. Well, in this world, you can fix it, but you're going to make version 2. You're not going to make our model, our old credit model, out of date. Instead, you're going to make version 2 of bank balance. The bug's been fixed. And at that point, we can then go and train a new model that works off of the fixed feature, and we can point to that. So in this world, we have a process for fixing our features, a process for updating our models. And we don't have to deal with this weird world of inconsistencies where we have an old credit model that's trained on a buggy feature, and we have to leave it all up and running because the model can't be updated when we update the feature. So that's versions in a nutshell. Of course, we can also just leave the old credit model running. We can have the new credit model running alongside it. Both of them can point back to bank balance. Each of them just picks a different version. So all of that's supported by the feature service. A nice little benefit, side benefit of having features. So in summary of all that, feature definitions, you saw they're consistent. There's a framework. New features are really easy to build off of all those shared components. And versioning allows for backwards compatibility and bug fixes, as I demonstrated. So bringing it all together, we've seen these things: data abstraction, common source, the simple framework, the caching, the analytics, the monitoring. And then internally, of course, we have consistency, easy development, and versioning. So at this point, you're probably asking, should I build one of these myself? A few questions you might ask yourself, a few questions that we found the answer was yes. Is feature quality a problem for you? This was definitely a problem for us about a year ago. This was an area we really felt we needed to invest in. Are all of your data sources complex and varied? If you're working off of a single data source and it's pretty simple, you can probably just keep your pipeline pretty simple. But for us, we were adding a lot of new data sources. We really needed to deal with that situation. Are you trying to support multiple models? Our CEO got excited about machine learning, wanted to see it everywhere. I imagine that that's the case at many companies. And so for us, we needed a way to support development of new models, exploration of new models, and supporting them when they're actually in production. Finally, are your features difficult to compute? For us, our features were pretty slow to compute, and so the speed up from a cache was really, really important. We, of course, have benefited greatly from this thing. Feature generation time dramatically reduced. We fixed a lot of bugs, as I mentioned. We can make new models without rebuilding our feature set. New data scientists can come in and contribute features and code within weeks of joining. This is something we experienced recently, a very exciting benefit we didn't even think about. And of course, we've been able to then iterate and improve on our model performance. So that, of course, was the end goal of this whole process. So what should you take away from all this? Hopefully, what you can take away is that a small company can build something too. You don't need to be Airbnb with a lot of engineers to build this thing. The trick, however, is to be strategic. And if you're going to be strategic, I recommend investing in a feature service. A lot of benefits for us, and hopefully you see some benefits in this for yourself as well. All that said, stay informed, come to conferences like this, go to meetups, all those things, because Airbnb may open source BigHead pretty soon. There may be other things on the horizon. This is a common problem space where there aren't a lot of solutions yet. So keep your eyes open. If somebody else builds something, you don't necessarily need to build it yourself. So with all that, I want to thank the team that worked on this. We had Dennis, Dave, Ting Ting, Nick, and myself. Again, a pretty small team working on this thing. And all these people contributed. And if you'd like to get in touch, I'm Spencer at branch.co. And I'm happy to take any questions.
Can you talk more about the details of the feature store? Like, what are the keys in there? And in particular, it seems like date is going to be something important. How do you handle when you have quickly changing features?
Yeah, so I guess a few points there. I can maybe go back real quick to, let's see if, I don't know, this technology. Whatever, we're not going to worry about it. So one of the things you probably noticed is that we've got this idea of like a primary ID. Usually in our case, it's a user ID. So that's certainly that is the primary key in that feature storage, as you might expect. A secondary key that's really important for us is time. I mentioned this idea of how you might always be requesting features at a specific time. Sometimes you explicitly call out the time that you want them, but if you don't do that, it's implicit that the time that you want it is now. And so when we then store those features in the feature storage, you've got, say, user ID and then the time that the feature was actually created. So those are sort of the two keys. And then, of course, the feature itself is, could be any number of things. It could be, Booleans or whatever. Again, DynamoDB, all these NoSQL tools give you a lot of flexibility. So we just have a blob that is basically, a JSON blob that is our feature itself. So those are sort of the two primary keys. Yeah, it's something like user ID and then the date where it was actually created. And then what was the second part to your question, I think, as well?
Do you need to do anything special to handle quickly changing features? Because if you have these two primary keys, then you might have one user with a date every single day because of a feature that changes.
Yeah, so for us, our time scale right now for feature changes is usually on the order of we're dealing with loans that last a month. So our time scale tends to be more like a month. So in our case, we just store whatever the features were at that time point, we store them. But you can imagine if things are changing really quickly, maybe you just want to store the updates. One of the things that we end up doing with our text message data in particular, I didn't talk too much about how we actually architect our data, but that ends up being a really important part in terms of dealing with time. So with text messages, for example, those are constantly updating, as you might imagine. And so we just store the updates. We store, if you're familiar with SCD tables, we store them in an SCD format, I think type 2. But the idea there is that you have a text message that shows up, we keep track of the date it showed up, and then if it disappears, we keep track of the date that it was deleted. And the combination of those two dates lets you sort of figure out what the state of the world was at that given time. But you're never having to store. There's a sort of another idea, which is that I might store a snapshot of the text messages every time I get them, but you end up duplicating a lot of data. So if you're getting a ton of data coming in, it's not changing too much. something like SCD tables, you can look up. The Wikipedia page is a great explanation. That's a good place to start. You might just store the updates. Yeah. Thank you.
Yeah, thank you. How strict are you in pushing all like data transformations into the feature store? Like if somebody wants to do some weird imputation strategy or interaction between two features, are those stored as completely distinct features in the store, or does any of that ever happen in the modeling area?
Yeah, that's a good question. So, I think one of the interesting ideas that we've been exploring is this idea of, we sort of realized that you don't necessarily need to separate out your model from, or models from your features themselves. A key idea behind this might be like, if you take text messages, raw text message data is interesting, but what happens if you instead embed it? Now you've got a much more interesting data format. You can work with that much more flexibly. It's, it's a vector of numbers. It's a lot easier to work with. That, of course, implies a model, however. Like if I'm going to train an embedding model, where do I put that? I could put that inside the feature service. And so one of the things we've been exploring is, let's have a feature that takes all the text messages and creates an embedding for it. And then you might use that embedding to develop other features. So I might use that embedding to, I don't know, build out my credit model. And so you've then got a dependency hierarchy where you've got, extractors, transforms, defining one feature, but you've got another feature that then calls that feature to use that data. So we haven't really built that stuff yet, but that's, I think, very much something that could be built, would be relatively easy. You can imagine sort of a graph framework of feature interdependencies where you compute features, utilize them in other places. And I think putting models into the feature service makes a lot of sense. There's no reason that a credit score shouldn't be a feature. In our world, for example, a credit score could be a feature into a different model. It could be a feature into the LTV model, for example. So yeah, no reason not to do that. Yeah, you just got to build it.
Yeah, I got a couple questions. I guess the first of which is, do you ever generate multiple features in a single Python thing? Because your example with the average and the max, there's a lot of computation that goes into extracting from SMS and then doing all that junk, right? Do you guys batch that together in a single job?
Yeah, so a concept I didn't really touch on, but with our API, we don't tend to call individual features. That doesn't really make a heck of a lot of sense, because what you just talked about, like, I don't want to pull all those text messages. I mean, that ends up being a lot of data for us to pull. So we usually, if I'm developing, say, I want the feature set for the credit service, I'm going to ask for all the features at once. So we have this idea of a feature set, which would be predefined. It might include maximum bank balance, average bank balance, and so on. All of those guys are going to be requesting text messages, and so there's actually a second layer of caching in here, which is the extractors all have their own cache as well. Or not a unique cache, there's a shared cache for all the extractors. So text messages end up getting pulled once, even if they're getting used for multiple features. So that deals with a lot of what you're talking about. We haven't addressed the idea of transformers being really complicated. They tend to be pretty simple in our world. But you can imagine if a transform took a long time to compute, maybe you'd want to do some caching in there too. But we haven't really explored that option yet. For us, it's really the data pull that's the slow part. So we do include a little bit of a caching layer there.
Cool.
Yeah. Yeah, you could imagine doing, if you did your hierarchy of features and that whole crazy graph thing, you might utilize the fact that a feature is cached. That embedding, for example, that I mentioned is an earlier example. You might cache that and then utilize that in 10 different places to develop a bunch of features. All interesting ideas. Yeah.
Yeah. Okay. Thanks. The other question I have is, do you differentiate at all between feature serving versus feature generation? Like if you get a request on demand to run this model for this one person, you might need to go calculate those features on demand. But if you're training a model, you need to go and generate a ton of this data all at once to create your training set. Do you guys have a concept of that?
Yeah. So I think there's sort of a few things that I didn't explicitly mention, but are implicit in sort of our problem space. And one of those is that we are doing online inference. A user shows up, they want a loan right away. We need to credit score them right away. There's, of course, the batch use case, which is pretty common for, I think, a lot of companies. Really, machine learning ends up living in batch. During training, of course, it lives in batch. So for our feature service in the API, we have, I think the primary API is the one I showed you, which is, hey, we want features, we need them right now. The secondary one is you're going to pass in a collection of primary IDs, a collection of dates that you want, and the features that you want. So when we're generating a training sample, we say, hey, we want these we want these 150 features. We want them for these, 500,000 users. We want them at these dates for those 500,000 users. And those will be the dates that they, for example, took out a loan in the past. And that then ends up being the request. So there's a second API that is sort of our bulk API.
Okay. Yeah.
Yep.
Thanks.
I think we have time for one more question. Any questions on the other side of the room?
I was wondering how far back you store the data for the date part, and how many versions, and how do you decide that, basically?
Yeah, that's a good question. So we, I think by virtue of only having a few million customers, haven't had to throw any data out or deal with the costs of all that. We've been able to keep it all. So we haven't thrown any out. I think that, if you're going to be throwing data out, you probably throw out the old stuff, I guess. For us, a lot of what that means is, our business was very different 3 years ago. We were getting very different customers. So we don't actually even use that data in training anymore. But data storage is cheap. I don't know. You look at the S3 costs, you might as well hold on to it. It's dirt cheap to hold on to all that. So what was that? That was the first part of your question. What was the second? So you've got, Oh, versions. How do we decide? Yeah, how do we decide what versions to do? So versioning, we version whenever we change the logic. So bank balance was the example I used in my slides. While bank balance, the idea is if the logic that defines bank balance changes enough that the value that would come out could change, then you need to version it. And that's really important. I mean, just to sort of hammer home that concept, I think one of the problems that you can sometimes get between folks who are really familiar with engineering and really familiar with data science and machine learning systems is that a model is immutable once you've trained that thing. It's up, it's running, but it expects certain data in certain formats. And so when you go and change the underlying data, when you change the feature definition, when bank balance all of a sudden you used to include cents and now you round it off, well, the model expected cents to be present, and so it's going to get confused. And it's going to get confused in ways that you might not notice for a while either, that's a problem that we've run into in the past. We changed our Facebook features, or Facebook changed their API, our Facebook features changed, and 6 months later we said, oh wait, 6 months ago things broke. That's a very common problem. So for us with the feature service, versioning happens whenever we change the logic, whenever we fix a bug. And generally, because it's easy to version, if we're changing anything in there, if somebody goes in and says, hey, this feature is running really slow, let's optimize it. We say, okay, you can optimize it, but let's version it. And so we'll copy paste, we'll start a new version of it, just to be on the safe side. It's easy to do, why not be on the safe side? So that's sort of our philosophy at the moment.